I live in the Chicagoland area. I live in the suburbs of Chicago, and I've been with Databricks for about a year and a half now. How about you, Denny?
Hi. Well, thanks very much, Franco. My name is Denny Lee. I'm based out of the Seattle, Washington area, specifically in Juanita, Kirkland. Been hanging out here for 20 odd years or so now. So definitely aging it, I guess. I've become a little bit of a wimp now that I live out here, but definitely enjoying it. And yes, it's actually sunny. So, Dylan, why don't you go next?
Hey, I'm a solutions architect here at Databricks. Been here for about 2.5 years, based in the New York City area. I work mostly with customers in the New York area and kind of the Northeast in general. So, a lot of digital native startups that are based in Manhattan, a lot of ad tech, fintech. That's kind of my focus area right now. And, here to kind of work with Franco and Mary Grace and, kind of walk through the SmartSQL capabilities that we have.
Cool. And my name is Mary Grace Musta. I'm a customer success engineer here at Databricks. I'm based in Detroit, Michigan, so I'm in the Midwest. I live in Brush Park, if anybody's familiar with the Detroit area. And I have been at Databricks for about 18 months now, a little over, and I started working with a lot of the customers that Dylan had mentioned. So a lot in the New York area, in the New York City area, doing a lot of ad tech, fintech, that kind of stuff. And then a few months ago, I pivoted and I now work with larger customers in the retail and CPG space. So kind of been able to see a good variety of, smaller companies to larger enterprise scale deployments of Databricks and, handling data at scale.
It's awesome. So we're all over the place. We're in 3 different time zones. Is Detroit Eastern or is it its own special thing? I forget. I think it's like the daylight savings time is weird somewhere around that area.
So I think it gets really weird around like South Bend. I think like right by the border of Indiana, Michigan, and Chicago, and Illinois rather. But Detroit's Eastern, so we don't have our own special time zone.
I got confused. So we got 3 different time zones. We're all across the United States, and we're going to work together on this.
Yeah, that's a little bit weird. How we're gonna pull this off? I mean, we're certainly not in the same room, let alone anything else. This is gonna be odd. So I wonder how we're gonna work together here, boys and girls.
Let's get started. Do we want to pop open the notebook and share screen? Dylan or Mary Grace, do one of you kind of want to get us started?
Sure. And meanwhile, for everybody else that's currently on the line, by all means, if you want to chat, we have the chat window. There's a Q&A window that we normally do for webinars, but for this session, because we actually want to encourage discussion, just chuck it into the chat window. If you're on YouTube Live, you're more than welcome to chime in there. I'll be monitoring that as well. So you can tell us what you like about what we're doing. You can tell us what you don't like. You can ask questions. By all means, chime in here. But remember, the context of today's session is to talk about smart SQL queries. In other words, you're taking your SQL queries, you're all going, yeah, I've got SQL queries, except can you make them more powerful? Can you power them up so they can actually do more things? And so that's the purpose of today's session, where we're talking about how you can create these smart SQL queries using a combination of what Spark SQL already has, running on top of the Delta engine that allows us to go ahead and use Python or Scala for that matter, but we'll probably use Python today, in order to be able to run our machine learning models, for example, and all on top of your Lakehouse. So that way you're not busy going ahead and rebuilding and building new infrastructure for no good reason. You're actually leveraging the infrastructure you already have. So again, chime on in if you got questions. For that matter, I would love to know where you're from. So if you want to, again, prop in the chat and let us know where you're from, because right now we are a little bit US centric. I was actually supposed to be doing this out of Taiwan, so my bad for not being there, but it is what it is. So at least I'm in a similar enough time zone at least. So no complaints, I guess.
You were supposed to be in Taiwan? I didn't even know about that.
Oh, no. It was one of those things. We were originally planning to go to Taiwan. We were thinking about going to Taiwan before the pandemic happened. And then because of everything that happened, we would have been forced to stay there. So
the world has gotten different.
Yeah, hasn't it? Cool. Meanwhile, Dylan, why don't you go ahead and pop open the, share the screen, excuse me.
All right, let's do it. Thanks, Denny.
Rock on.
All right, so I should be sharing now. Can you guys see my browser?
We can.
Looks good.
Yep.
You might want to zoom in a couple times just to make
Yep,
sure anybody who's in it.
Yeah.
Merci
Give kind of
beaucoup.
the overview.
Perfect.
Awesome. So we're looking at the notebook now, and this is a Databricks notebook, right? You can see we are in a SaaS-based solution. I'm at this URL. This is kind of our shared internal demo workspace that I can access from the browser like so. That being said, all of the actual storage and compute that we're going to be working with in the notebook is actually going to be in as a customer of Databricks, it's going to be in your AWS environment, right? So we kind of do that for security and lock and avoidance type reasons. So you can see here in my workspace on the left-hand side, you can see these are kind of the main notebooks that I work with. I'm focusing on specifically this notebook that we prepared for you guys today, and I can jump in right here. Now, what you'll notice is I'm seeing some flashing letters over here on the screen up here in the top right. And this actually might look familiar to you if you've used Google Docs before, or Google Sheets or Google Slides or anything of that nature. These are basically other people logged into the notebook right now. Right, and so the reason we're able to do this is because we are that SaaS-based solution, and you can see who is this. Yeah, that's MG. She's showing us that the real-time changes, and I can actually just go back here to an earlier version because I don't think we need that comment right now, but thanks, MG. So the reason we're able to do this, right, is because this is this Databricks native notebook experience, right? And I often describe these as Jupyter inspired or Jupyter based. But really, while that kind of invokes this idea of a very data science centric environment, right? So we're thinking about these kind of exploratory data analytics and machine learning type use cases where you get this kind of interactive feedback in the cells. Really, this is meant to encompass both those kinds of data science use cases as well as support ability to switch languages. And because SQL is a first-class native API on top of Spark, we're actually able to use this and treat it more like a query editor. So a lot of people actually will just use this as a SQL notebook and basically use it as this interactive way to do SQL-based business analytics, as well as kind of interactive ETL development, where we'll do actual ETL development directly in the notebook and get kind of immediate feedback. And then we'd be able to productionize this through the Databricks job scheduler in a bit. Which we can talk about later if we have time, but really the focus here is going to be more on how do we actually use this from that kind of more pure SQL perspective, but able to switch languages over to Python in areas where we kind of need that extra power of a more procedural based language as opposed to being limited to the kind of declarative language that is SQL, right? So you can actually see here, I think that was MG cloning that command as well. You can actually see here, I'm actually going to start with Python for the initial Databricks notebook setup, right? So what I'm doing is I have these widgets, and these widgets basically make it easy. If I'm kind of a power user who wants to get this all set up and then have other analysts use it, I can actually have them quickly enter, maybe some metadata about the kind of session they want to have once they start writing their SQL commands. I'm going to set it to my database. And this is shared across other users in the workspace. And I'm also going to set up this path, which will be relevant later once we get into some other use cases. But you can see if I click on this data tab right here, you can actually see I can also kind of treat this just how you would with other RDBMSs where I have access to the different tables. And I'll get into what this means in a bit.
So essentially your Python programmers can parameterize the actual Python code so that SQL analysts can just put in their parameters and execute the code. They don't necessarily need to know what's happening.
Yep, that's exactly right. Let's actually go ahead and roll back. I think MG's been making a couple of changes, so let me just go ahead and roll those back. But let's run that Python cell that you're talking about there, Franco. And you can see here what I'm doing is I have this attached cluster, and I can have other people on my team go ahead and use this. Because it is this Databricks runtime, it comes prepackaged with all the libraries that I need. And then we'll get into kind of how we can do some nice caching features as well on this cluster. So while we're waiting for this to run, I'm going to go ahead and preface the kind of key concept that I want to convey in this notebook today. I actually have 3 sections, and I have these collapsible cells here on the left to kind of demonstrate to you the 3 kind of layers of this ETL pipeline that we're going to be working on. So I'm going to be talking today first about data ingestion, and then I'm going to be talking about how we can then build some analytics ready refined maybe data marts or aggregate level tables. And then I'm going to hand that off to MG, who is a bit more on the kind of line of business side, and she can show you how you would actually do everything from kind of traditional analytics all the way to machine learning within the same single notebook. So let's talk a little bit about how we got here. As most people are probably familiar with, I know we have in our audience a lot of people with DBA backgrounds who have probably worked with these kind of traditional data warehouses in the past, right? So these are traditionally these on-premise, large-scale, fixed capacity appliances. And then, we have that fixed capacity. We do a lot of this upfront ETL before it even gets in there. And we define a schema ahead of time. We try and match that schema basically to the reports that we know we're going to need, right? We fast forward a little bit, turn of the last decade, we start seeing a lot more investment in machine learning and AI. We start seeing a lot more unstructured and semi-structured data coming out of new digital data sources, et cetera. And then we also see the advent of big data and Hadoop and HDFS and all these things going on, kind of create this new paradigm called a data lake. All right, so over the last decade, at Databricks, we've been positioned at the front and center of a lot of these deployments. And we've, created this storage layer called Delta Lake that's been designed to address a lot of the things that we found really challenging when people started building these data lakes. Okay, and so what Delta Lake attempts to do is deal with a lot of the kind of hard system level thinking that you typically had already solved for you in the data warehouse, RDBMS SQL world, but we're solving that in data lake world on top of cloud object storage at that lower cost of cloud object storage, at that large scalability of the cloud. And as a result, now that we're able to kind of take care of a lot of that systems level thinking, you can instead redirect your time towards reasoning about how I can build out these hops from raw data over to refined data, over to aggregate data, which I'm going to hand off to MG in a bit. But it looks like our setup is good to go. I'll pause here. Any comments from my teammates? Or?
Hey, there's just a couple questions I want to address in the chat real quick and to try to tie a couple things together. So the question came up, is Delta Engine the same thing as Photon, and is it GA? Delta Engine is what we call the Databricks version of the entire ecosystem. So Dylan had mentioned that he's using Databricks Runtime 7 with the ML version of it. So we consider the image that we put together of all of the configurations and everything just working with our opinionated approach to all of the different configurations and performance items. We call that Delta Engine, Databricks Runtime. Photon is a part of what that is going to be included in the engine. Databricks Runtime or Delta Engine is generally available on the platform today. Photon is a new part to essentially vectorize the compute so that it's more taking advantage of SIMD architecture of modern processors. Essentially, it's going to get better performance, brings it closer to the machine. The other question was about distributing the notebooks. I think we can share these, right, Dylan?
Yeah, definitely. And by the way, all the data that you're seeing here is in a path called Databricks datasets. And if anyone has a Databricks workspace already deployed, you'll have access to that. It's basically default data that comes with the workspace. So you guys should be able to get up and running with these notebooks.
Great call out. So we are primarily using all of the Databricks data sets that's available within Databricks, and you don't need any special permissions. It's just included in the runtime. There was a follow-up question about Spark SQL, about performance. SQL, the main reason why I think we're kind of showing how this works is that when you leverage the power of SQL or Spark SQL or all of the different constructs that go into this, and I'll touch on this a little bit more later on, but essentially it allows you to declare what you need in SQL language, right? Which I consider SQL lingua franca of like data people. If you mess with data, odds are you speak SQL, right? So it's a way for us all to communicate in a way that we all understand. And performance-wise, it's the same. Whether I think there's some graphics recently that we could probably share that shows the performance metrics between all the different APIs. Essentially, Spark is working behind the scenes to improve the performance of your queries. You don't necessarily have to do very much to mess with it on Databricks because it's the Databricks runtime. We kind of configure Spark and Delta to work really well within our environment. And the performance, you're not going to see a difference whether you're doing data frames or you're doing Spark SQL. It's kind of the same thing. With RDDs, it's a bit different. We don't really use those APIs as much anymore. So hopefully those answered your questions. Dylan, I'll give it back to you. Sorry for the sidetrack.
Awesome. Yeah, thank you. Super helpful background there. So let's get started with the first part, data ingestion. Right, so we have this, what we're going to do a little bit differently with Delta than you might have be doing, done in the past with your data lakes is we're actually going to go ahead and create a pristine raw table representation of each data source that we're working with. And oftentimes, if you've worked with Databricks architects before, we'll often call these bronze tables. That's not an actual official definition. That's just kind of, one of the ways we like to refer to it, because you'll see we'll have silver and gold in a bit.
Oh, actually, Dylan, just to interrupt on that one point, we actually did recently release the VLDB paper 2020 Delta Lake for high performance over highly available storage, cloud storage, object stores. That actually is our reference now document that actually does call out the Delta medallion architecture of bronze, silver, gold. Middle enough, this was literally we published this late last week. So yes, just want to call that out. Sorry.
Awesome. So it's official now. So this is officially a bronze
table. It is
table.
Official now. It is
according to
we can call it.
The academic literature is
exactly. The academic literature says so now. Yeah, so I think we're good to go now.
It's true. Awesome. So I'll rewrite this to say bronze table, but the value really here why we're doing it this way is because we have this raw bronze table, we can go back to this for debugging and troubleshooting purposes. We can go back to this to build new ETL pipelines off of, and we can even open up access to people like MG who has some data science background and actually might want to be experimenting with a new, deep learning model or something that actually wants the kind of large scale unaggregated raw data. And so, because of the low cost of S3, we don't have to think so much about, what actually makes it into the data marts in the warehouse, and just do it this way. So the first example is if you already have Parquet data on S3, we can do a simple convert to Delta. This is what's called an in-place conversion. And notice again, this is all SQL, right? So we write a lot of this and directly into SQL. This is basically built into Databricks. I just have a notebook up and running and I can start running these commands. The reason why we can do convert to Delta and do this in-place conversion with Parquet is because I mentioned Delta as a storage engine earlier. It's actually a bit of a misnomer. It's actually none of the actual data, if it's in Parquet, actually needs to move at all. What we're really doing is we're adding an additional metadata layer on top of existing Parquet that allows us to keep the data in a fully open source format. And we actually have open sourced the metadata format as well, right? So that's all now owned by the Linux Foundation. But what this allows us to kind of keep your data in one place, There is no cost if you ever want to get off of Delta. There's no cost in terms of data transfer. There's no cost in terms of open operability of people accessing the data. And again, as I mentioned earlier, because the data is all like in your S3 bucket, there's no kind of transfer cost as well. So that's the first example, right? And I'm basically copying over this data. This is some Amazon review data, right? So I have some text data, and then I have a 1 to 5 rating for each of these Amazon items. Okay. So let's say we are not working with Parquet data, but we still want to leverage Delta downstream from that. What we'll do instead is we'll actually convert that data into a Delta format, and you'll be able to use Delta, the name Delta, just as you would any format like Parquet, JSON, CSV, et cetera, on Spark. This is pretty much all I need to do. So I'm just doing a basic CTAS statement, referencing some JSON in S3. We kind of abstract out the work it takes to actually get that path on S3, and you can kind of just treat it like a file system. And then I'm going to do a select star here. You can see this is some IoT data. And this was kind of just flat, right? But we do support semi-structured data. If I were to have some nesting in the station, I would be able to support that semi-structured data in Delta as well. Okay.
Hey, Dylan. So we've been calling out S3 here, but it also works on Azure very similarly with ADLS, right?
Yeah, definitely. So in Azure, we support ADLS and just standard blob storage on Azure. We actually designed Delta to work with any cloud object storage and HDFS as well. I'm just simply kind of speaking in Amazon world to keep things simple, but you're absolutely right.
Yeah, I just want to make sure we call the distinction. It's not just on AWS.
Absolutely. By the way, let us take a quick break just to answer some quick questions here. For everybody, I just recently chimed in. Again, you were asking about the notebook. The notebook is actually going to be available at the Databricks Tech Talks shortly after this session, usually about 48 hours. We'll have a pull request. We'll push it through, and you'll be able to see it there. We've already put the link of the Databricks Tech Talks actually in both the chat on Zoom, if you're logged in this way, or if you're on YouTube. We've already popped on the YouTube chat as well. So you'll be able to see that location. And then in addition to that, hey, Dylan, we've got a great question right away. You've been busy talking about Delta Lake, and we're wondering if in terms of, I've got a bunch of data sitting in Parquet, in my ADLS location, can I convert this into using Delta Lake? And so, well, for the panel.
Yeah, definitely. So it would look pretty much the exact same as this example one here. You can see this is Parquet data, right? And I can even take this if you want. I can use DBFS, which is our file system abstraction on top of any blob storage, ADLS, Azure Blob, S3, et cetera. And I can actually take a look at, this is my raw Parquet data, but you're going to see when I do that in-place conversion, you can see this is my existing Parquet. This is just gzip, snappy, like partitioned Parquet data. And everything I should expect, this is S3 specific stuff, be a little bit different on ADLS. But you can see we have this Delta log, and that's going to look the same on any blob storage. This is basically that transactional log and additional statistics that we track that allows Delta to do its thing, right? Cool, so I can go ahead and—
Awesome. No, that was great. Thanks very much for providing the clarification. And for everybody that's currently on the line, whether you're on Zoom or YouTube, by all means, keep on asking the questions away. Some of them we're going to be able to answer directly via chat, but for some of them, we'll definitely bring them on air and answer your questions live.
Awesome. The last thing I want to call out here is not so much an example, but a lot of we show the convert, the in-place conversion and the create table as select, et cetera. But a lot of our customers actually that I work with, what they're doing is they're choosing to bring another ETL tool that makes it really easy to support connectors to thousands of external systems, right? So you're talking about Google Analytics, Salesforce, the list goes on. This is just kind of a peek at the Databricks network of partners that we have native integrations with. So this will make it really easy to be able to take either this notebook, run it as a job as part of kind of a larger graph of tasks, and then integrate with pre-built connectors to each of these systems. Okay. Same goes for databases over here on the left. Most kind of popular SQL databases we have native integrations with that a lot of people are using today. So let's talk now about part 2. We are going to be building these refined, maybe we call them data marts. Now officially, these are going to be called silver tables. And then aggregates, many people call these gold. Sometimes people even call them platinum tables. But these are basically report ready, things that maybe your CEO cares about that we're good to go working with. The first example I want to use here is actually an upsert statement. And so one of the things we can do with Delta now that we're tracking all that metadata about the Parquet files is we can take things that previously would take a multi-step process, right? And now become kind of this one single transaction, and Delta will kind of deal with the rest under the hood, right? And so I have this merge into statement. This is all kind of pure SQL, and I can build this right in the notebook. I can basically, have a when match statement, have a when not match statement. And traditionally in Parquet, this would be a 7-step process. I have to identify my things to delete, update, change, right? Because Parquet is immutable. I have to do these individually. With this, I can basically do the entire thing as a single SQL statement, right? So those are upserts. The other thing I want to point out here is that a lot of these features, we talk about like bin compaction and talk about Z ordering and DBIO caching, and like the list of features to a lot of people can be kind of overwhelming when we first start getting into Delta and in Databricks. But a lot of this has a pretty strong corollary to what you're kind of working with traditionally, like in SQL, right? In RDBMSs, right? So in Optimize, basically what this does is it will find the optimal size of Parquet partitions, right? So if you think we're going to talk about streaming in a little bit, you think, usually with streaming, you have to make this trade-off between latency and file size, right? You have to think about your trigger interval and think about, how big your micro batches are going to be. And what often ends up happening is you run into this thing we call the small file problem. And this is a common thing that we've seen a lot in data lakes. Optimize basically originally was meant to solve for that, but it's also a pretty easy way to just kind of manage partitioning automatically, right? I say indexing, really the command Z ordering, they're pretty similar. It's basically a way of us kind of having a secondary index on a column. You can really think of it like that. Under the hood, Z ordering is using this high dimensional clustering algorithm. We choose that because it makes it, if I were to add, like say I were to add some additional columns here, I don't have as much of a degradation on performance when I'm doing those kind of additional columns that I'm indexing on. That's basically what the Z ordering does. But I can basically use this in addition to my partitions to add kind of external indices. Final thing to point out here is, yep.
Hey, Dylan, I just want to, do you have strategies? And this is kind of I'm leading the witness here, but when we're talking about partitioning and Z ordering, do you have like a general recommendation to make like which columns you should partition versus which columns should be Z ordered? I have ideas on it if you kind of don't have guidance, but in general, like, do you ever get asked that? And then what's your normal recommendation?
Yeah, definitely. If, it's always going to depend on the use case. But in general, I usually start, what I usually tell my customers to start with is partitions are going to be a lot harder to change. Whereas because the orders are not actually, touching the Parquet data itself, we can make changes to those more easily. So oftentimes people will start partitioning on first a timestamp or date time, and then second on some business object that we know is not going to change, like for example, an account ID or something, or object ID. And then Z ordering is going to be more based on the query patterns that we're seeing from our analysts, like additional columns outside of the timestamp and the business object that we see there could be some query impact on query performance if we Z order.
Actually, this is a very good because we actually have a couple questions on YouTube Live as well. So the first thing is, could we describe a little bit about the impact of performance by converting from Parquet to Delta? You already provided some guidance, especially to call out the fact that there's things like to optimize, but I'm just curious if there's any other things we want to do, including the fact that, or not including the fact that we have partitioning improvements and things of that nature.
Yeah, so there's a couple things that are actually happening automatically that I'm not calling out here. And I haven't talked about caching on its own has a pretty big impact, right? So what we do there is when you have I-series instances, or I'm talking again in AWS world, but we can basically cache to external block storage for some repeated queries. So that's one thing. Another thing that I haven't shown here at all is just data skipping. And so this is kind of like, we will push down predicates, right? If you have a filter clause, we are tracking statistics, basically the kind of mins and max of Parquets, and you can think of it kind of like a Bloom filter. Basically what that's doing is, if I'm just searching for a very specific range, out of, a massive multi-terabyte data set, I might actually only have to open up 1 in every 100 Parquet files, right? So I'm basically 1% of the initial overhead just from data skipping. And that's just something that you're going to get with Delta. Partitioning helps with that, optimizing helps with that, because it's going to optimize the file sizes. But those are the kinds of optimizations that you're going to see automatically. Now, if we talk about like order of magnitude in general, right? If we look at kind of industry benchmarks like TPCDS, right? This is kind of a common data warehousing benchmark. We'll often see, through these techniques, when used correctly, we will see a roughly 10x order of magnitude improvement just in these kind of TPCDS kind of industry standard queries.
Hey, just to kind of add a little bit onto there. So when we're talking about Z-ordering and partitioning, these are different ways to kind of structure data so that you can get faster queries at runtime, right? When you're either getting interactive queries ad hocly from users, or you have standard reports that hit these queries or these tables often. And when we're talking about, what optimize brings, so partitioning strategy and Z-order strategy, it's kind of like in the database realms. Denny, I know that this is your background, right? You were on various teams that kind of did SQL for various engines, but it's kind of like scan versus seek, right? If you can find the min max of a column and you have a partition, so you know how your data is split up, and then you have min maxes, you can essentially seek versus scan all the data, and you get much better performance. So that's kind of how those two worlds are related. Would you?
Absolutely. So if you think about it, when, for example, you're looking at a relational database, often we talk in terms of scanning the files and trying to make sense of, like, just like I said, looking at the headers to make sense of what is in there, so you can basically only grab the information you care about. In the case of when we're working with Parquet, even by itself with Spark, right, we actually will look at the Parquet footer files, so that way we can actually figure out which ones to process. Now, that's still scanning, but at least you're only looking at the footers to figure out which files you need before you go ahead and jump in, jump out. Now, what's interesting is that when it comes to Delta Lake specifically, we actually list the files that actually make up that version of the data. So because you're doing that, now it's actually better than a scan or seek, because now it's a list. We don't actually have a listing on a cloud object store. Doesn't matter if we're talking S3, ADLS, blob storage, or whatever else, can be quite slow, right? So the fact that we already have the files listed because they're actually included within the transaction log of Delta Lake, what ends up happening is that now we know exactly which files to grab. So there's no seek anymore. We just grab the ones we need to go grab right from the get-go. And then we do some additional processing to figure out which of those files, which one do we actually need. Now, that's where the optimize and all partitioning, indexing, caching, all that stuff kicks in. But the idea is that we actually do a bunch of these optimizations even before you do the next seek that you're talking about. So yes, absolutely agreed.
Yeah,
I hope this makes sense, by the way. Yeah.
Yeah, it's a great thing to point out, because a lot of people, S3 is always, or any, cloud blob storage, you're going to ultimately get bottlenecked at some point when you're doing large scale list commands on a large directory, right? And oftentimes we won't actually feel the impact of running into those bottlenecks until we're talking like petabyte scale. But nonetheless, there is that overhead. And basically by going to the Delta metadata store instead of having to make those list commands to blob, we're still kind of reducing that overhead. There's also a cost component too, as well. Obviously per API call, it's going to be relatively small. But if you look at a lot of people's bills, when they look at total spend on cloud storage, about half of that actually makes up of just API calls, and a big chunk of that's just lists, right? So that's a great thing to point out. Last thing I want to point out before handing this off to MG is I'm going to actually swap back with my magic command. I'm going to swap back to Python again. And the reason I'm doing this is I want to actually go from batch into streaming. One thing that's nice about Spark is that we support both batch and streaming under the same API, right? I'm going to say read stream here instead of read. If you guys have played with the PySpark API, this should look familiar. But I'm basically going to be able to take this bronze table and then move it right over to the silver table. And then I can then in concurrently with that, while that stream's going on, I can do this select star from that same silver table, right? And so this is basically, it's using snapshot isolation, right? I can kind of have an isolated picture of that table when I'm running this query, and I don't have to worry about having like a separate batch read like in tandem with the streaming architecture, like this kind of streaming command, right? So a lot of times what people will historically end up doing is they'll build this kind of Lambda architecture, right? Well, they'll have to have this streaming analytics on kind of one swim lane of the architecture, and then running batch maybe at the end of the day on a completely separate part of the architecture. This basically would unify all that, because I can then take the different parts of this multi-hop pipeline, convert those parts to this real-time streaming when I think it makes sense. And I don't have to worry about the hard consistency and snapshot isolation type properties that you typically would have to worry about. All right, so instead, with Delta, I can basically run this select star, and you can see here, this should be chugging away. It pretty much finished the processing, and it's just kind of going to sleep now. But there is no kind of concurrency issues that I ever run into when doing this select star. Last thing to point out here is because we are tracking a log of those transactions, we are able to do rollback. So I can specify an as of command. I'm doing a describe history here, and you can see every change I've made to the silver table. All right, so I did the create table, I did that merge, and then I ran that optimize command. And I can then go down and I can point to, for example, should be able to just say version, let's see, version as of version 0. And I should be able to see go back to an earlier version of this notebook. Maybe one of you guys can help out and put the.
Oh yeah, it shouldn't be. It should be version as of 0.
Should be version as of, right?
Yeah.
Let's try the bronze table maybe.
Yeah. Oh, it looks like there's only 0 versions. Yeah.
Right. That's the issue.
So there you go. Yeah.
Just gonna give you an overview of what that would look like.
It's all good.
Cool. So now I want to hand it off to MG, and she can kind of take it from here. Go ahead and stop sharing.
All right, Mary Grace.
So
rock it.
Let me jump into the right screen here. Okay. So Dylan just kind of talked through the way that we can kind of walk and like look at the path of historical data. One way that we see this like manifesting in customers really frequently is in GDPR and CCPA use cases. And again, we won't get too into the specifics, but especially when it comes to using this vacuum command. I think that this actually came up in the chat of, Delta is a bunch of version parquet files. How do we clean things up on the back end so we're not, if we don't need to store all of these versions for the end of time, how can we kind of be smart about storage costs? And that's where vacuuming comes in. And so in this case here, we're using the vacuum command to clean up our bronze table, anything that is older than 720 hours. So again, it's going to go ahead and clean up all of those version parquet files. That way, number one, we can make sure we're not storing things that we don't need to store. But then also number two, in cases where data privacy is a concern, you're able to go ahead and easily pull out those version parquet tables and, to meet compliance for GDPR standards or CCPA standards as well. And then again here, right, we can use this describe history to go ahead and look at the history of what's happened to, in this case, our bronze table. But we have the ability to kind of like look at that audit path using our describe history and describe extended commands in Delta too. So that's kind of the ETL part. And I'm going to focus on the third part, which is the analytics side of things. So if we're kind of like summarizing what we've done, we've got these bronze tables with all of our raw data. We've got these silver tables where we've merged some records into them. They're cleaned up a little bit. Now we're going to build what we're calling these gold tables, which is again where we often see analytics teams, machine learning teams pulling from these refined tables to actually go ahead and execute, any basic analytics, business analytics use cases, or even machine learning, which will show both. So, and again, gold tables are oftentimes aggregates, right? So if we're looking at some of the tables that we already have, we can kind of build our own roll-up table that's going to aggregate things that's going to help us answer whatever business question we're looking at. So if we are, actually, I'm just going to kind of wave my hands here because we're running a little short on time. But essentially what we're doing here is we're creating our gold table, our IoT roll-up gold table, and we're using Delta again too. So again, this is the syntax that Dylan had showed a little bit earlier. And what we're doing is we're going to select our device name, the CO2 level, and the battery level directly from our bronze table. And then we're going to group by a roll-up of device name, the CO2 level, and battery level, and order it by both battery level and CO2 to get, again, this nice aggregate table that our data scientists and business analysts can pull from. So looks like this thing is connecting here. Can folks still hear and see me okay?
Yes.
Definitely.
Cool. Okay. Awesome. So while that runs, I'll go ahead and just start to write out what else we're going to do here. So we'll build this table. And then if we just run a select star from our IoT rollup goal, we'll be able to see what that data looks like.
So behind the scenes here, the Delta Lake APIs are doing all the underlying file-based operations on the object store. You're basically just telling it declaratively with SQL what you want it to do. And it's Delta Lake API that actually gives you the power to be able to issue those commands, right? So it's kind of like a leverage of a couple different properties that's going in here.
Mary Grace, I think you're on mute right now. Sorry, Mary Grace, you might be muted right now.
Right now. Can you hear me?
We can hear you now, yes. And you might want to share your screen as well. For some reason, the screen sharing also disappeared as well.
Goodness gracious.
I know. This is what happens when we do things live. It sucks.
Yeah, I know.
It's the real world.
So everybody on the line, you know that we're actually doing this live and with little to no practice.
This is how the real world.
So again,
right?
Yeah, this is how real life collaboration works. Is you gotta take a couple stabs at it. So we've got our rolled up gold table, and again, this is what it looks like, right? So we've got our device name. We're ordering it by the CO2 level and the battery level. And so now that we've kind of created this gold table, let's actually before we kind of query directly from it, let's put into practice some of those tools that Dylan was talking about earlier. So let's optimize the table. Optimize our IoT roll up gold table. And again, that's going to help with some of the small file problem. And then we'll Z order it. Z order by the battery level. And in this case, right, the reason that we're choosing to Z order by battery level is because if we think about like query patterns down the line, you know, battery level will be something that's frequently filtered by. So we're able to kind of speed up our query times because it's Z ordering by that piece of, you know, by battery level and that metadata. So we can go ahead and skip data more efficiently. So then if we're going to go ahead and actually query, you know, we can do a really quick select count star to get our total number of records, or total devices rather, from our IoT roll up gold table, where the battery level equals 0. Equals 0. So again, we'll kick that off to run, and you can see that we've got just under 20,000 devices that are dead that we need to look into. Cool. And then
Not really cool. That's a lot of dead devices.
Yeah, it's a lot of dead ones. As opposed to we've got 60,000 totals. That's like a third of all of our devices are. Wait, that's not 60,000. 600,000. Sorry.
I guess not as bad. Yeah.
It's not as bad. Probably should decrease that number though.
Fair enough.
So again, that's kind of the pattern, right? Of being able to pick up this goal or create this gold table and then Z order it and kind of optimize it in the background with Delta. So when folks are querying directly against it, you know, we can take advantage of like the data skipping and bin compaction that lives within Delta. Okay, cool. And the last part is we'll kind of move into a machine learning example. And, you know, I think oftentimes, like when we think about machine learning, it's not always synonymous with, oh, let's do this in SQL, right? Most machine learning happens in Python. But there's actually a few different ways, and we'll walk through one of them here, where you can build your machine learning algorithm in Python, but you can register it as a Spark UDF, which is what we're doing here. So you can interface with it in SQL. And so we'll switch back to Python again, just for this though, so we can build our machine learning algorithm. And in this case, we're building a NLTK sentiment analysis model, which is just going to take some of that Amazon data we had earlier with the reviews and the like open text comments. And we can analyze some of those comments, right, to better understand the overall sentiment of these comments, and we can aggregate from there. So again, this is just importing some of the base modules from NLTK, building our sentiment model, and then registering it as a Spark UDF here. And this is, again, this line here that's registering it as a Spark UDF is going to be the way for us and for downstream analysts to interface with this model through SQL. And so what we can do is, we'll kind of go through this guy. So let me kick this off. So we've built our model, and what we're doing in this SQL query is we're actually sending it the data from our Amazon data and passing it to the model that's been registered as a Spark UDF. And that way we'll be able to, what will get returned is the output of the model itself. So it'll be the Amazon data, you'll have the reviews, you'll have the free text field, and then it will have the output of the model itself. So it will have the actual sentiment. And again, you'll see this is all in SQL, right? So folks who are native in SQL and more comfortable, you don't have to worry about switching to Python and like overcoming that barrier to entry of being able to navigate PySpark. You can send requests to your model in SQL, outright as it's been registered as a Spark UDF, which I think is pretty cool. I don't know about other people, but
I think it's pretty cool. Basically, as a SQL analyst, I don't have to learn Python. I don't have to learn NLTK, which I tried to boot that up myself, and I was having difficulty. And I can call someone like Mary Grace, who understands those modeling techniques, and I can Slack her a link where I'm doing my work, my notebook. She can put in the necessary Python code and just give me a function, and then I put that function into my code, and now I can build smarts right into my SQL queries. That's awesome.
Yeah, and so you'll see the output here as we've got the rating review and then the underlying return of sentiment, right? And again, this is like the raw output of the model, and it may look, not super formal, and it can be aggregated and rolled up and kind of formatted so it looks a little bit nicer when it's returned. But essentially, you're able to get the model output back, so you can talk or look at the sentiment of or roll up the aggregate sentiment of your review, all still using SQL, right? You can kind of ETL and explode this return and aggregate it up from there. So yeah, that's kind of like the super quick example. But again, like we use a really basic NLTK model here. This applies, for all machine learning, all different types of algorithms, whether it's, shallow learning, deep learning, supervised, unsupervised, right? We can kind of work with a data science community and abstract away some of the complexity, and then register it as a UDF, so SQL analysts and business analysts can go ahead and interface with, some more with, these complex models through SQL.
And one thing I would definitely love to add to exactly Mary Grace's point. So first things first, we have the concept of smart SQL. So the smarts is because we have somebody like Mary Grace who actually understands the machine learning in order for us to be able to have that. So in other words, me as a dumb SQL guy, I'm being very facetious. I think SQL people are pretty smart, by the way, but I'm just calling me a dumb SQL guy. We can depend on somebody like Mary Grace to be able to basically allow us to go ahead and be able to improve the smarts of our SQL. But the other key thing to note is that some folks, I've gotten this question in the past, so I figured I'd just jump it out right away. They're going to say, hey, well, yeah, how do you parallelize that? After all, UDFs aren't the great to parallelize. So don't forget, we have pandas UDFs now, vectorized UDFs. So because of that, then you're able to go ahead and parallelize that process. So you're actually able to distribute the processing to all of your workers with very little change to your code base. Okay, I mean, there is changes, don't get me wrong, in order for you to parallelize stuff. But the fact is, by being able to use vectorized UDFs, you're going to be able to distribute the workload and make full use of your entire cluster. So that's how your SQL becomes really smart. And that's the call out about a very opinionated version of what Lakehouses are supposed to be able to do.
I think it's really interesting. I really like your point, MG, about how we're basically abstracting the development of the model from the deployment of the model, right? A lot of times the hardest part about ML isn't even ML. It's how do I actually then take it into production, which is, often can be overlooked in a lot of cases. And a lot of times people say, all right, let's do kind of what we've done with traditional software engineering. Let's put it on a REST API. Let's put it on a server somewhere. What this is saying is we can have this accessible to a SQL analyst without having to necessarily deploy a REST API or like a microservice. What I can even do is if I want to start doing real-time scoring and I want to actually start powering applications with this, I can actually take this and then move it over to a stream like I had shown in the previous example. And now I'm actually doing real-time machine learning scoring without even having to deploy a server to do that.
Yeah, exactly.
A lot of really cool things you can do with this.
So really powerful stuff. So we've got only a few minutes left, so please do ask questions. And we're going to end the session, by the way. Oh, sorry. There was a question about parallelizing that I had mentioned. I'm referring to pandas UDFs or vectorized UDFs. We actually, if you go check out the Databricks blog, we actually have a lot of blogs on how in Apache Spark 3.0, we've significantly improved how vectorized UDF or pandas UDFs have worked. So I definitely advise you folks. In fact, I'll go look for the link right now as other people chime in. So.
Yeah, that's a good call out there. You know, leveraging the power of pandas UDFs, and even recently with Spark 3, you know, most people say that Python, PySpark, or Python within the Spark ecosystem becomes more Pythonic in how the new pandas UDFs are actually structured within Spark now. That, you know, it actually brings a lot, I would think, a little more clarity to Python programmers on how to leverage those types of techniques using arbitrary Python code. So we definitely have content there. If you're looking for examples of different ways to distribute and parallelize your Python code, we do have kind of examples on different ways that works with pandas UDFs. Thanks, Denny, for posting the blog.
Yeah, and then there is another question too about when you register Spark UDF, will it make the model available to everybody, or can you selectively control who can run the model? I believe, and again, someone can fact check me on this, but I'm pretty sure it registers to that Spark context, right? So it's ephemeral to the cluster.
Oh, sorry. Yeah, we're all nodding, but people probably not necessarily seeing it. Yes, we're in agreement with you on this one. Sorry.
So in terms of like putting ACLs per se on like that UDF, I don't think you technically can. You'd have to put ACLs on the cluster, would probably be the best way to like persist that like security layer to a model that's been registered as a UDF.
So you know, just want to make sure that abbreviations, some of these things everyone might not know, but ACLs, access control lists. It's what is a abbreviation we like to use often, but that's what ACLs are. So basically controlling who can have access to it. And the thing I want to kind of identify here is that there's the model, which is persisted to some object store, and you could put access control or ACLs on the specific cloud store. There's then ML flow, which helps you manage the life cycle of a model that you have in your organization. Then when you use model registry, you can use access control on model registry, right? There's ACLs in there. So it all depends on how you implement it. But if you have specific requirements or SLAs, reach out to an SA or a CSC at Databricks if you're an existing customer like Mary Grace is. Or if you're just a developer out there learning, Denny is our developer relations. You know, you can reach out to Denny. Dylan and I are solutions architects. We work in the field every day with clients and prospects. So if you have ideas and you want to know if Databricks can help, reach out. We can help you.
Perfect. So actually, I'm going to wrap this up by saying thank you very much for Dylan and Mary Grace for this awesome, fun session for our inaugural Franco and Denny session of Data Collab Lab. I did want to end it off with the fact that we do actually have another session coming up next week. Let me just go ahead and share my screen real quick. We're going to change gears massively, but this does showcase a little bit about the fact that we at Databricks covers a lot of cool things, including the fact that we're next week on the 8th of September, we're going to be talking about genomic variant data ingest and manipulation using Project Glow with Amir and Kavash. So it'll be if you're at all into genomics and healthcare life science, we highly advise you to come on over to this session. It'll be a lot of fun. Same idea. You'll be able to chime in, ask us questions as we do our presentations. And before we leave, I did want to call out the fact that if you've got some other ideas of other queries that questions that you want to ask us, whether it's about this session, don't forget this session's actually playing on YouTube Live right now. So we'll be so go ahead and chime in on the comments where the four of us will go ahead and answer your questions there. And in addition to that, if you've got some cool ideas about what you'd love to talk about with any of us, by all means, go ahead and chime in. Let us know so that way we can continue the Data Collab Lab. So that's about it for today. Again, I wanted to leave Dylan and Mary Grace with the last two words since they're the featured guests today. So anything you'd like to add before we wrap it up?
No, just thanks for coming, everybody. It was a lot of fun. And again, as Denny said, feel free to reach out with any questions, Databricks related or anything based on the session today.
Perfect. Dylan?
I second exactly what Mary Grace said.
All right, perfect. Rock on. Franco, anything else you'd like to add before we wrap it up?
That was awesome. Thank you, everyone. Like Denny said, bring us your toughest problems and we can work on them live with some of the smart people that we work with.
Perfect. Well, that's it. That's a great way to end it. So thank you very much, everybody. Appreciate your time, and we'll see you next week.